Hi children, welcome back to Vidyarthi Tutorials. So children, in the previous class we have seen exercise 1.1 from chapter 1 integers. So today we are going to see some of the properties regarding the integers and also exercise 1.2. Shall we start our class now? Then let's begin our class now. Properties of addition and subtraction of integers. So let's say the first property, closure under addition. We have learnt that sum of two whole numbers is again a whole number. For example, 17 plus 24 is equal to 41, which is again a whole number. We know that this property is known as closure property of addition of the whole numbers. So children, in the previous class, that is in 6th class, we have learnt about whole numbers. In that what we have seen, so if we add any two whole numbers, we get again a whole number. For example, here we have taken 17 and 24. So 17 plus 24 is 41, which is again a whole number. So let us see what happens in the case of integers. Let us see whether this property is true for integers or not. Following are some pairs of integers. Observe the following table and complete it. So here we are having a table. Let us complete and see what we are getting and align the observation over here. So look here, 17 plus 23. We are getting 40. So 17 is an integer, 23 is an integer, and the result is also an integer. So result is an integer. So minus 10 plus 3. So here we are having two opposite signs. So whenever we are having two opposite signs, what we have to do? We have to subtract those numbers and keep the highest number sign. So here 10 minus 3 is 7 and 10 is the highest value and 10 is having the negative sign. So we get minus 7. So minus 7 is also an integer. So result is an integer. So next, minus 75 plus 18. So here also we are having two different signs. So what we have to do? We have to subtract those numbers and keep the highest value sign. So subtract 18 from 75. So we get 75 minus 18. So we cancel out here. So here it is 6 and this is 15. So 8 plus 7 is 15. So here 7. 6 minus 1 is 5. So we get 57. So here the highest value is 75. So it is minus 57. So minus 57 is also an integer. So the result is an integer. Understood children? So similarly we have to do all the statements and observe each and everything. So what do you observe from the above observations? Is the sum of two integers always an integer? Did you find a pair of integers whose sum is not an integer? So do you find any of the integer which is not, that means sum is not an integer? So since the addition of integers gives integers, we say integers are closed under addition. So all the time we get an integer. The result is always an integer. So whenever we are adding two integers, we are getting integer as an answer. So addition is satisfied. So integers are closed under addition. So in general, for any two integers a and b, a plus b is an integer. So this is the property. So whenever we are having any two integers, so a plus b is also an integer. Okay. So for any two integers a and b, a plus b is an integer. So this is closure property under addition. Understood children? Next property is closure under subtraction. So previously we have seen closure under addition. Now we are going to see closure under subtraction. What happens when we subtract an integer from another integer? Can we say that their difference is also an integer? So now we are doing their difference. So we are subtracting an integer from the other integer. So let us do and verify. So here we are having statements and we have to observe and write the observation here. So 7 and minus 9. So 7 minus 9. So here 7 is an integer, 9 is an integer. So 7 minus 9 we get minus 2. So minus 2 is also an integer. So the result is an integer. So let us do the second one. 17 minus 21. So 17 is an integer. Minus 21 is an integer. So minus into minus becomes plus. That means 17 plus 21 is 7 plus 1 is 8. 1 plus 2 is 3. So how much we are getting? We are getting 38. Is the 38 an integer? Yes, 38 is also an integer. So the resultant is integer. So the result is an integer. Next, let us solve the third one. Minus 8 minus of minus 14. So if we solve this, we are getting 6. So minus 8 is an integer, minus 14 is an integer, and the result 6 is also an integer. So the result is an integer. Understood, children? So try to do all the statements over here. Now what do you observe? Is there any pair of integers whose difference is not an integer? Can we say integers are closed under subtraction? Yes? Yes, we can see that integers are closed under subtraction. So here, every time we are getting the resultant as an integer. Whenever we are subtracting any two integers, we are getting an integer itself as a result. So integers are closed under subtraction. So we can say that integers are closed under subtraction. So thus, if a and b are two integers, if we take a and b as two integers, a minus b is also an integer. So a minus b is considered as an integer. That means the resultant is also as an integer. So understood, children? So this is closure property under subtraction. The next property is commutative property. So next property is commutative property. We know that 3 plus 5 is equal to 5 plus 3, that is equal to 8. That is, the whole numbers can be added in any order. In the other words, addition is commutative for whole numbers. So for whole numbers, what happened? So we are taking any two whole numbers. Let us take 3, 5. So if we add these numbers, how much we are getting? 8. So if we reverse these numbers, that means 5 plus 3. Again we are getting the resultant as 8. That means this is also a whole numbers. So 3 plus 5 is equal to 5 plus 3. So this is equal to this one. So this is commutative property for whole numbers. Now let's see what happens in the case of integers. Can we say same for the integers too? So let us take one example and solve and say whether it is satisfying for integers or not. So here we have 5 plus of minus 6 and minus 6 plus 5. So here we are taking 5 and minus 6. So let us verify. So 5 plus of minus 6. So plus into minus we get minus. So 5 minus 6. 5 minus 6 means minus 1. Because highest value is having negative sign. So we are keeping minus. So minus 1. So 5 plus of minus 6 is minus 1. And minus 6 plus 5. Minus 6 plus 5. So if we are doing this one, we are getting minus 1. So here also minus 1. Here also minus 1. Now, so 5 plus of minus 6 is equal to minus 6 plus 5. So we can write like this, no? So this is equal to this one. Now, are the following equal? So let us do some more examples over here and verify. So minus 8 minus 9. So minus 8 plus of minus 9. That means minus 8 minus 9. Minus 8 minus 9 we get minus 17. Just wait, children. So minus 8 minus 9 we get minus 17. So next value is minus 9 plus of minus 8. That means minus 9 minus 9 minus 8. Minus 9 minus 8 we get again minus 17. So here both the values are same. So minus 8 minus 9 is equal to minus 9 minus 8 now. So here we are getting answer as minus 17 only. So this is also correct. So let us verify all those things and say. So will you all do now? So try this with 5 other pairs of integers. Do you find any pair of integers for which the sums are different when the order is changed? So, whenever we are changing the order, do you find any difference? So, if you are not getting the answer equal, that means they are not commutative. But we are getting equal all the time. So, we can say that addition is commutative for integers. Addition is commutative for integers. In general, for any two integers a and b, we can say that a plus b is equal to b plus a. So, if we are taking any two integers, the addition, that means a plus b is equal to b plus a. Okay children, so this is commutative property under addition. So remember this children. So this is the property. Next, we know that subtraction is not commutative for whole numbers. Is it commutative for integers? So this is under addition. Now let's check out for subtraction. Okay, addition of commutative property has been satisfied. Now what happens with the subtraction? Consider the integers 5 and minus 3. So we are taking 5 and minus 3. Is 5 minus of minus 3 is same as minus 3 minus 5? So 5 minus of minus 3 is 5 plus 3. So 5 minus of minus 3 is 5 plus 3. That means we are getting 8 here. So minus 3 minus 5. Minus 3 minus 5 is minus 8 no. So is 8 is equal to minus 8? 8 is not equal to minus 8. So they are not equal. That means they are not satisfying the commutative law. So this is not commutative for integers. So for under subtraction it is not commutative. Under addition it is commutative. Understood children? So next we are having associative property. So look at here examples over here children. Observe the following examples. Consider the integers minus 3, minus 2 and minus 5. So look at the equation over here. So this equation. So consider like this. So minus 5 plus of minus 3 plus of minus 2 and minus 5 plus of minus 3 plus of minus 2. So what we have done here? So we are taking in the associative rule. Okay. So in the first sum, minus 3 and minus 2 are grouped together, and in the second one, minus 5 and minus 3 are grouped together. So here observe the first one. Minus 3 minus 2 we are taking it as a group under the square brackets, and in the second one minus 5 minus 3, this one is taken under a group. Okay, so now we will check whether we get different results or same result. Let us verify now. So in both the case we get minus 10. So if we verify, we are getting minus 10 as answer. So here also minus 10, here also minus 10. So they are doing in the number line. Observe here. So here minus 3 plus of minus 2. Minus 3 plus of minus 2 is nothing but minus 5. So here we are getting minus 5. Minus 5 minus 5. So answer is minus 10. So in the next case, minus 5 plus of minus 3. That means minus 5 minus 3 is minus 8. So here we are moving to minus 8. After that what we have? Minus 2. So if we move 2 steps forward, we get answer as minus 10. So in each case we are getting minus 10 as answer. So both the cases we are getting the equal answer. So similar answer. That means we can say that addition is associative for integers. So integers is satisfying the associative property. So in general, for any two integers, any three integers a, b, c, a plus of b plus c is equal to a plus b plus c. So this is the property. So a plus of b plus c is equal to a plus b plus c. Understood children? So this is the associative property. The next property is additive identity. So let us see what is additive identity. When we add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. Is it additive identity again for integer also? So when we are learning whole numbers, if we add any number with 0, so if we are adding 0 to any number, for example 2 plus 0, we get the same number itself. So when we add 0 to any number, we get the same number itself. So when we add 0 to any whole number, we are getting the same whole number. So is it the case with the integers also? Let us verify. Observe the following and fill in the blanks. So minus 8 plus 0. So we are adding 0 to minus 8. So we are getting the same integer, minus 8 as the answer. So minus 23 plus 0. Again we get minus 23. So here also we are getting the same integer. 0 plus of minus 59. So plus into minus is minus. So we are getting minus 59 answer. So here also we are getting the same integer. So minus 61. If we add 0 to minus 61, we get minus 61 again. So 0 minus of plus of minus 8, we get minus 8. So here also we are getting the same integer. Next 0 plus of minus 37 is equal to minus 37. So here also we are getting the integer. 0 plus dash is equal to minus 43. So what we have to add here? Minus 43. So here we are getting the same integer. So if we add any number with 0, we are getting the same integer. So let us take it as minus 1. So minus 1 plus 0, we get again as minus 1. So from the above cases, what we can say? The above examples shows that 0 is the additive identity of the integers. So you can verify it by adding 0 to any of the other 5 integers and say whether 0 is identity property or not. So 0 is additive identity or not. So in general, for any integer, a plus 0 is equal to a plus 0 is equal to a or 0 plus a. Okay, so this is the additive identity for integers. So 0 is the additive identity for integers. Understood, children? Now let's move on to exercise 1.2. So here is your exercise, children. So in this exercise we are having total 4 questions. Let us solve each and every question in our class and do it. So let's see the first question now. So look at the first question, children. Question number 1. Write down a pair of integers whose sum is minus 7. So how we have to write? Their sum must be minus 7. That means when we add those two integers, we must get minus 7 as answer. So let us take any two integers and add those integers so that we have to get the answer as minus 7. So let us consider the integers as minus 4 and minus 3. So if we add these numbers, do we get minus 7 as answer? Let's see. So minus 4 plus minus 3. So we are adding those integers. So minus 4 plus minus 3. So plus into minus. Plus of minus means plus into minus. Plus into minus is minus. So minus 4 minus 3 we get minus 7. So first pair of integer is minus 4 and minus 3. Now let's take one more example. Let us take the integers as 2 and minus 9. So we add 2 with minus 9. So let us add these numbers. 2 plus of minus 9. So 2 plus of minus 9. So plus into minus it becomes minus. That means 2 minus 9. 2 minus 9. So here we have to subtract the integers and keep the highest value sign because both of them are having two different signs. So here it is plus 2 and here it is minus 9. So subtract each other. So if we subtract 2 from 9, we get 7. And 9 is having the highest value. 9 is the highest value and it is having the negative sign. So it is minus 7. So we have written the integers whose sum is minus 7. Understood, children? Now let's see the B question. So difference is minus 10. Now we have to write the integers whose difference is minus 10. That means when we subtract those numbers, we have to get the resultant as minus 10. Let us take the integers as minus 12 and minus 2. Let us subtract those two. Minus 12 minus of minus 2. So when we subtract minus 12 minus into minus we get plus. So minus 12 plus 2. So here we are having two different signs. That means what we have to do? We have to subtract each other and keep the highest value sign. So when we subtract 2 from 12 we get 10 and 12 is having the negative sign. So answer is minus 10. So this is the one set of integers whose difference is minus 10. Now let us take the other integers minus 6 and 4. So minus 6 and 4. Let us see whether we are getting the difference is minus 10 or not. So minus 6 minus of plus 4. So minus 6 minus 4 we get minus 10 as answer. So here we have written a pair of integers whose difference is minus 10. Understood children? Now let's see the next one, that is sum is 0. Now third bit, that is C question, is sum is 0. We have to write down the integers, a pair of integers whose sum is 0. Let us consider the integers as minus 4 and plus 4. So minus 4 plus 4. So both of them gets cancelled and answer is 0. So minus 4 plus 4 is 0. It is nothing but 4 minus 4. 4 minus 4 is 0, no? So answer is 0. So let us take one more pair, that is minus 13 and plus 13. So minus 13 plus 13. So both of them were having two different signs and the numbers are similar. So minus 13 plus 13, that is nothing but 13 minus 13. So 13 minus 13 is nothing but 0. So here also we are getting 0. So we have written a pair of integers whose sum is 0. Understood children? So this is how you have to write the examples. Question number 2. Write a pair of negative integers whose difference is 8. So here we have to write pair of negative integers. Underline that children. So we have to write the negative integers whose difference gives 8. So whenever we get difference, that means we have to do subtraction over there. So if we subtract those two negative integers, we have to get the answer as 8. So let us write those examples. Let the integers be minus 8 and minus 16. So let us consider those integers as minus 8 and minus 16. So we have to find the difference. That means we need to do subtraction. So minus 8 minus of minus 16. So minus into minus plus. So minus 8 plus 16 we get 8 as answer. Because here we are having two different signs. That means we need to do subtraction and keep the highest value sign. So answer is plus 8. So here we have got 8 as answer. Let us consider one more example, that is minus 16 and minus 24. So minus 16 minus of minus 24. Minus into minus plus. So 16 24. Minus 16 plus 24. We need to do subtraction, that is 24 minus 16. So we get 8 as the answer. Understood children? So here we have taken two integers, that two negative integers, and the difference is 8 over here. Understood children? Now let's see next one, that is B question. Write a negative integer and a positive integer whose sum is minus 5. So here they are asking us to take one negative integer and one positive integer, and we have to add those two integers and the sum must be minus 5. So let us take negative integer as minus 10 and positive integer as 5. So add those two integers sum. So minus 10 plus of plus 5. So minus 10 plus 5. We get minus 5 as answer. So here the sum is minus 5. So here we are taking a negative integer and a positive integer and we are adding them and the sum is minus 5. Understood children? Here you can take any of the integers on your wish. Not only these integers, you can take any of the integers such that it satisfies the given statement. Understood children? See the second next question. Write a negative integer and a positive integer whose difference is minus 3. So last question, question number C is write a negative integer and a positive integer whose difference is minus 3. That means we need to take a negative integer and a positive integer and the difference must be minus 3. That means we subtract those two integers, we need to get minus 3 as answer. So let us take negative integer as minus 1 and positive integer as 2. So difference means subtraction, no? Minus 1 minus 2. So minus 1 minus 2 we get minus 3 as answer. So here we are getting minus 3. The difference is minus 3. So this satisfies the equation. So the integers were minus 1 and 2. So here also you can take any of the integers, not only this question. So previous questions also you can take any of the integers on your wish according to the statement. So it has to satisfy the statement. Okay. So you can take any of the integers on your wish. Understood, children? Now let's see the question number 3. In a quiz, team A scored minus 40, 10, 0 and team B scored 10, 0, minus 40 in 3 successive rounds. Which team scored more? Can we say that we can add integers in any order? So here we have a quiz and there are two teams, that is team A and team B. So team A scored minus 40, 10 and 0 in 3 successive rounds. In 3 rounds they have scored minus 40, 10 and 0. And team B scored 10, 0 and minus 40. And then what they are asking? Which team scored more? They are asking us to find out which team has scored more. Can we say that we can add integers in any order? And also we have one more question, whether we can add the integers in any order or not. Firstly, let us add the scores of team A and team B and verify who has got more. So scores of team A were minus 40, 10 and 0. So let us do the total of score for team A. So minus 40 plus 10 plus 0. So we are adding all the scores scored by team A. So minus 40 plus 10. 0 has no value, no? So we are leaving out. So minus 40 plus 10 we get minus 30. So here we are getting minus 3 minus 30 as total score of team A. Now scores of team B. So scores of team B were 10, 0, minus 40. So add all the integers over here. 10 plus 0 plus of minus 40. So when we are adding this, 10 plus 0 plus into minus, it becomes minus 40. So 10 plus 0 minus 40. That is 10 minus 40. So we are getting here minus 30 as total. So team B total is also minus 30. So here also we are getting minus 30. Here also we are getting minus 30. So both the teams scored equal scores, that is minus 30. That means both of them were same. So we can say that addition of integers can be done in any order. So yes, we can add integers in any order. So who scored more? No one has scored more. Both of the scores are equal. Both the scores of the team A and team B are equal. So answer is both the teams scored equal scores, that is minus 30, and yes, we can add integers in any order. Understood, children? Now let's see the next question. Question number 4. Fill in the blanks to make the following statements true. So here we are having some of the statements and we have to fill them accordingly so that it becomes true. So minus 5 plus of minus 8 is equal to minus 8 plus of dash. So what we get here? This is commutative property of integers. So what we have seen, A plus B is equal to B plus A. So here A is minus 5, B is minus 8. So B is minus 8. So here we have done A plus B is equal to B plus A. No? So what we will get here? We will get minus 5 as answer. So minus 5 plus of minus 8 is equal to minus 8 plus of minus 5. Understood, children? Look at the next question. Minus 53 plus dash is equal to minus 53. So here this is additive identity. Additive identity. So additive identity is 0, no? So additive identity is 0. So here what we have to add to minus 53? So if we add 0 to minus 53, we get minus 53 as answer. So this is additive identity of integers. Understood, children? Look at the next question. Question number 3. 17 dash is equal to 0. So this is additive inverse. So we have seen additive identity, but we have not seen additive inverse now. So additive inverse is nothing but minus a. So additive inverse is minus a. So if we have 17 as a, so additive inverse of 17 is minus 17. So 17 plus of minus 17 is equal to 0. So answer is minus 17. So a minus a becomes 0. A and minus a. So additive inverse of a is minus a and additive inverse of minus a is a. So here we are having 17. So we are adding minus 17 to it so that we get 0 as answer. So answer is minus 17. Understood, children? So look at the fourth one, children. 13 plus of minus 12 plus dash is equal to 13 plus of minus 12 plus minus 7. So this is under associative property. So what is associative property? A plus B plus C is equal to A plus of B plus C. So this is the property now. So according to this property, if we consider 13 as A, minus 12 as B and minus 7 as C, so what we get here? Answer is minus 7. So A plus B plus C is equal to A plus of B plus C. Understood, children? This is question number 4. Look at the next question, children. Fifth question. Minus 4 plus of 15 minus 3 is equal to 15 plus of minus 3 is equal to minus 4 plus 15 plus dash. So this is also associative property. So what is associative property, children? A plus of B plus C is equal to A plus B plus C. So here consider minus 4 as A, 15 as B, minus 3 as C. So A plus of B plus C is equal to A plus B, that is minus 4 plus 15, A plus B plus C. So what is C here? Minus 3. So the answer is minus 3. So understood, children? So this is how you have to find out which property it is and fill the blanks here. Understood, children? So children, with this we have completed exercise 1.2. Hope you all understood, children. So if you have any doubts, you can comment in the comment box. So children, don't forget to subscribe and like and share. Thank you, children. Keep smiling. Thank you. Have a nice day.